All right, so today we're going to work with systems of equations, and our first method of solving systems of equation is by graphing. This is the least accurate method because you are graphing by hand. So sometimes this does cause a bit of a problem. We will talk about two algebraic ways to go ahead and solve systems. That will be another day. So today we're just going to go ahead and solve these by graphing. All we're going to do is we're going to take each line separately and we're going to find 2 points and graph each line. All right. So I'm going to take, I like to number these when I work with them. It is totally up to you. So equation 1 I'm going to work with first. Equation 1 is x plus y is equal to 2. And I can graph these using any method I want. I can use intercepts. I can use plotting points, whatever I would like. I want to go ahead and plot points for this. It really doesn't matter what I use. If I use intercepts, that means if I make x 0, right, that means that I have, if x is 0, I'm left with the equation y equals equal to 2, so y is equal to 2. If I make y 0, that means the y cancels out. I'm left with x is equal to 2. So I have 2 points. But I can also use any other point I want. I can make, okay, well, if x is 1, then 1 plus y is equal to 2, so y must be equal to 1. And I have a third point. All right. So I'm going to go ahead and plot my points in blue. So I have 0, 2. I have 2, 0. I have 1, 1. Notice they all kind of line up. And I have a line that's in blue for that line 1. Line 2, all right, is 3x minus y is equal to negative 2. And then again, I'm going to do an xy table. You can use intercepts or not. That might not be the best choice for both of these, given that you don't want to try to graph a fraction. But in this case, if I make x equal to 0, that means 0 minus y is equal to negative 2. Now, we're not solving for negative y, so we have negative y is equal to 2. If we multiply each side by negative 1 to get rid of the negative on the y, or divide, it's up to you, we have y is equal to 2. All right, and I kind of see that I already have a point in common, but I need at least one more point to graph this line. So I'm going to go ahead and make, I don't know, oops, sorry. Going to go ahead and make, I don't want to make y 0, because that's going to be kind of funny. But how about if I make y negative 1? Let's try this out. So I have 3x minus a negative 1 is equal to negative 2. So I have 3x plus 1 is equal to negative 2. If I subtract 1 from each side, I have 3x is equal to negative 3. And if I divide by 3, x is negative 1. That works for me. But you remember, you can use any points you want. Fractions are going to be a little tricky. It's going to be a lot harder to graph it. I try to go for whole numbers whenever possible. And you've had enough experience graphing lines that you should be able to kind of have an idea of what kind of points you would like. So I have 0, 2. And I have negative 1, negative 1. And if I wanted to, I could get a third point. And my line goes up through. And my solution for both of these is going to be 0, negative 2, 0, positive 2. Because that's the point that I have in common in both my charts. But you don't necessarily have to have them on your charts in order for it to be a solution to your graph. So this is a scenario where we have one solution. Let's look at example 2. Again, I'm going to number these 1 and 2. And let's work with 1 first. So I have x minus 2y is equal to 4. Again, I'm going to pick some points, see what I come up with. 4 is a nice even number. That's great. So if I make x 0, it means I have negative 2y is equal to 4. If I divide by negative 2, because I have a negative in front of my y is equal to negative divided by a positive is a negative 2. I could work with that. That's a nice whole number. We can go ahead and make x 2. I mean, again, it's your choice. You could do whatever you would like. So if x is 2, I have 2 minus 2y is equal to 4. Subtract 2 from both sides. Negative 2y is equal to positive 2. Divide again by negative 2. Negative divided by negative is a positive, so y is equal to negative 1. Or sorry, negative divided by positive is a negative. And negative 1. If I wanted to, I could plot a third point. I could make y 0, which would make x 4. You could do the math for yourself. I'm going to graph this one in blue. This will be my blue graph. So I have 0, negative 2, 2, negative 1, and 4, 0. They line up pretty well, considering this is a nice hand graph. And I'm going to go ahead and graph my line. Working with equation 2, which is x is equal to 2y. This is going to be a little bit easier, because there's a couple ways I could do this. All right, I know that if I plug in for y, I'll automatically get my x because I just have to do the math. If I make y 0, 2 times 0 is 0, which means x is 0. If I make y 1, 2 times 1 is 2, so x is 2. I could go ahead and even go as far as negative 1, which would give me negative 2. This one was really easy to go ahead and do. So it's important also that if you have something in the form of y equals mx plus b, to use that slope and y-intercept to your advantage. All right? So I'm going to graph this one in red. So I have 0, 0. I have 2, 1. And I have negative 2, negative 1. And I'm going to go ahead and graph my line. Now, even though this is a hand graph, we could totally see that these do not cross. And they appear to be parallel, which means they have no solution. They are nowhere crossing anywhere from it. And we could kind of verify this by going ahead and saying, okay, well, the distance from on the y-axis is 2. From here, now let's pick another color so you can see it. From here to here. Let's pick a different color. I'm not doing good at this today. So from here to here is 2. From here to here is 2. From here to here appears to be 2. And from here to here appears to be 2. So it appears that this is going to be parallel. There is exactly 2 between each line. So there's going to be no solution to this graph. All right. Let's look at example 3. So example 3, we have 2 equations. Again, I'm going to number them. Work with equation 1 first. 2x plus 4y is equal to 10. I'm going to go ahead and use intercepts with this because I just don't want to deal with anything else. So if x is 0, the 2x goes away. Oh, that could be kind of messy, so maybe we don't want to do that. because I'm going to get a fraction. So let's make y0, because that's a nice even number. And that means I'm left with 2x is equal to 10, so x is equal to 5. That's a nice number. From here, we got to do a little bit of playing around. So I'm going to say, okay, I'm going to make y1. You're saying, why am I working with 1? Because we want it to stay even. And if we go ahead and multiply that out, I have 2x plus 4 times 1, which is just 4, is equal to 10. If I subtract 4 from each side, I'm left with 2x is equal to 6. That's a nice number. And if I divide by 2, x is equal to 3. And I have 2 nice points I can go ahead and graph. I'm going to make this in blue. So 5, 0. Make sure you're graphing your points correctly. And 3, 1. All right, I'm going to go ahead and connect these 2 points. This is where we're not really sure if this is going to work or not, but we'll see. Our next line, line number 2, is x plus 2y is equal to 5. I'm going to kind of use the same thing I did with 1. I'm going to make y0 first, because that gets rid of that 2, because 5 is odd. So I have x is equal to 5. Boom, nice and easy. I can go ahead and make y1. This is going to be too bad. So I have x plus 2 times 1 is equal to 5. If I subtract 2 from each side, x is equal to 3. Not horrible. I'm going to graph this in red. So I have 5, 0. And I have 3, 1. And we notice that those are the same 2 points we got for the other line. So this line goes right on top of the other line. And this one has infinite solutions. So every solution for line 1 is a solution for y2. Right? Let's go ahead and recap really quick. All right. So if you have one solution, all right, that means you have one solution, xy, that satisfies both equations. And we have some terminology that goes with that. What we do is, because there is a solution, we call this something called consistent. And because each line is its own entity, which means there's 2 separate lines going 2 separate ways, these are also called independent lines. So they're independent lines or independent equations. Okay. If we have no solution, at all, then these 2 lines are parallel. Okay. Which means these 2 lines, because they never cross, are inconsistent. But because these are their own lines, they're 2 separate lines, these are also independent. If these 2 are the same line, okay, which means as we go through, these are the same line, so they both overlap, and they look like one line. Because they have solutions, these are consistent. Okay, because there is a solution, there just happens to be a lot of them. But these are the same line, so these are dependent. Okay, dependent, because they're literally the same line. They're right on top. These are not two separate lines. These are the same lines. All right? So go ahead and work on the problems we have, and I will see you in the next video.